conferences. In other, he was an organizer. We are very sorry that he is not with us now. So three of the people who most interacted with him, three of them will now say some words about Alexandro.
Okay, my name is Paco Guinea from Madrid and also now Manchester, and I'm really appreciate the opportunity of being here and in order to show my respect and my admiration for Alejandro Muramatsu. I mean, I really enjoyed his friendship a lot. I'm starting with, I mean, there are no pictures, basically no pictures from the time we met each other. That was 82, winter of 82 at Santa Barbara in California. But I took this slide because I was given an award some time ago and I had to give an overview of my career, and I started the presentation by discussing my postdoc years at the University of California, Santa Barbara, and there was the director at the time, Walter Kohn. That was the place where the now KITP was located, Ellison Hall in the campus, and those were three colleagues with whom I interacted a lot, who eventually became very close friends of mine. But with all respect to Gershon and to Vincent Kim, my really closest friend during those years was Alejandro Muramatsu. I really, at that time, I mean, I arrived to Santa Barbara during the last days of September 1982, way back. And Alejandro arrived in early January 83. Somehow he knew that I was there. We had already met in a few conferences. So he showed up in my office, introduced himself, and that was the beginning of a great friendship, like in the film Casablanca. We collaborated scientifically. We had a number of papers from that time, Vincent, Alejandro and I, and then we continued collaborating later. I profited a lot from that collaboration. I learned a lot from Alejandro. I mean, he was a master in all kinds of techniques, both formal and numerical. I mean, he knew a lot of physics, but he was also a very good friend. I imagine that quite a few of you have been or know Santa Barbara. Santa Barbara is a great place. I'm very proud of having been here. That really made a change in my career and probably in the career of everybody who went there at the time and later. It was an excellent place scientifically, and people worked very hard, and you had very good colleagues, and that was great for all of us. But it was a bit dull. I mean, to tell you the truth, Santa Barbara is a small city. The student ghetto surrounding the campus, called Isla Vista or A La Vista, according to the Americans, was even duller than the downtown area, and the reason I survived was because of my friendship with Alejandro. And that's the truth. So I really enjoyed his friendship. We had similar opinions in many matters of life and everything. We didn't agree on everything, but that also made room for very interesting discussions and conversations. And we basically stayed together the whole 2 years we spent in Santa Barbara, and then we continued our meetings and so on. I went to Würzburg when he was in Würzburg, then to Stuttgart, and he came to Spain a number of times. Eventually, scientifically, our paths diverged, so we met less often. But every time we met, we really enjoyed our new meeting together. I mean, it's too bad. I mean, that people like him, who really enjoy life in all situations, who know how to get the best of life, no matter what, are no longer with us. It's a fact. Let me just finish. I don't want to be too long. As I said, I really have to thank Alejandro for a lot of things. He was an excellent friend, and also a person from whom you can learn a lot of things, not only physics. And just to finish with an anecdote, the influence of Alejandro will last for a very, very long time, because thanks to him, my son, daughter, and wife got addicted to sushi. The reason being that at that time, in the 80s in California, fish was terrible. I mean, they basically burnt it. And in Spain, we are very fond, like in Portugal, we're very fond of fish. So it turns out that thanks to Alejandro, he also, as a Japanese Argentinian, he loved fish as well. and he introduced me to sushi. I introduced sushi when I was married and had kids to the rest of the family, and they're very much aware that they appreciate sushi from before sushi was fashionable, thanks to Alejandro Muramatsu. And thanks for you a lot for your attention.
Okay, so I did prepare some like short presentation because I have a lot of pictures with Alejandro, so I had to make a selection there. So let me just start by telling you that I met Alejandro in 2001. So when I moved to Stuttgart, so he was my PhD supervisor. And then last night I was thinking, okay, what are the first memories I have from Stuttgart? And the first memories are like really work. Okay, so work. So because at the time I arrived to Stuttgart, Alejandro was very excited about the idea of learning things about strongly correlated systems from ultra-cold atoms in optical lattices. So essentially, Alejandro, Richard Scaleter, and George Batruni, they were really very early on, they realized that those systems were amazing, when many condensed matter physicists were saying like, oh, maybe not, maybe they are just reproducing what we know. And I mean, one of the things that fascinated us at that time was this issue that if you have a homogeneous system and you want to get a Moore insulator, you have to essentially fine-tune the filling, okay? And in these experiments, they couldn't quite control the filling, so essentially, and you see it in here, so something that was amazing to condensed matter people at the time is that one can have in these ultra-cold atoms, one can have like a Moore insulator for many different fillings. So essentially the idea Alejandro and Richard and George had was really to study those systems with unbiased techniques, and that's why we started using quantum Monte Carlo. So in this collaboration, so essentially George and Richard, they were focusing on the bosonic part, and Alejandro and I were focusing on the fermionic part. And we were discussing a lot in these early times, and Alejandro was also very interested on this problem of quantum criticality. So essentially in the second paper, which we focus on the fermions, what we started thinking is, well, what happens in these systems when you, in space, go from a metallic phase to a more insulating phase, as opposed to the way we do it in condensed matter, which is just by changing interaction or just changing some chemical potential. So, and that's how we came to realize that there seemed to be some kind of critical behavior, and we went and wrote up these two papers. Now, as time went, things got better. It was just not work only. So I started getting to know Alejandro better. And there was something that he used to do several times a week, and it was to swim. Okay, so he loved swimming, and I learned that I think he was swimming since he was an undergraduate, and probably he was in a team in Buenos Aires. So I love to run. And at that time, someone came to the group, Reinhard Noack, who loved to bike. So essentially, at some point, we realized that there was a triathlon, and they allowed people to have teams. And then we made a team. Alejandro did the swimming. We actually did pretty well in that. So he was always emphasizing, you know, it is important to exercise, but also it's important to have fun and to drink. So after we finished, we went out for a drink, and here you have Reinhard, and this was a postdoc at the time. So the other thing that we physicists do a lot is to travel. So I also had the opportunity to travel with Alejandro quite a bit when I was a graduate student. So for example, this is a picture at the School of Strongly Correlated Systems in Vietri. So where Alejandro was teaching about quantum Monte Carlo techniques, and essentially you see the view is great. So and we I think all enjoyed a lot his lecture. Okay, so At that time, actually, this was 2003, at the end of 2003. I can tell you that Alejandro was a bit critical of the German system because somehow it's very tough for young people. So essentially, at that time, he told me like, well, it's time for you to wrap up your thesis and move on. Essentially, he suggested I should go to the US or to France. So, and this is, I just wrote the thesis, and this was right after the defense. So in Germany, or at least in Stuttgart, there is this tradition that you should get a hat, a PhD hat, and then there are all sort of things in the hat. I think Alejandro found something there that he found funny. So essentially, that was about the time that I left Stuttgart. There was obviously some celebration also, and you see he always had this big smile. Okay, so then what happens after? So interestingly enough, when I left Stuttgart, we still collaborated a lot. So, and what we discussed a lot after leaving was this problem of quantum quenches and how do you describe these systems after they equilibrate. So this was the second paper that I wrote about this generalized Gibbs ensemble description of integrable models, and you see Alejandro is there. We discussed a lot. So you see at that time, we didn't even say quench. So this is what now people call a quench. And the GGE was just like a generalization of the Gibbs distribution. So yesterday I was going through my publication and seeing, well, how important was Alejandro in the work I did over the years. And we actually wrote 18 papers together, and half of them were written after I left Stuttgart. So essentially we were a lot. He also made some very important contributions shortly after on really quenches in generic non-integrable systems. So this was a very influential paper and actually made me think about this problem more, and it contributed to this idea of eigenstate thermalization. And he was also interested in what happens with how correlations spread as a function of time. So they also wrote this very influential paper. Now, after I left, it was also not all about work. So I came often to Stuttgart. So this is a picture in 2006. We went now for a group lunch, and there you see Alejandro. So there are a couple of things that I should tell you. So Alejandro was always a very generous supervisor. So I don't remember going for lunch and in one of these opportunities like this, going to somewhere else and paying for it. So he essentially invited, he treated the entire group. And another interesting thing that you can see in that picture is somehow phase separation. You see the alcohol drinking people over here and the non-alcohol drinking people over here. So we phase separate there. But the other thing that I always did, or he always did, for me when I went to Stuttgart is he always had me for dinner with him and Heidrun. So he was a great cook. So that was the highlight of my trips to Stuttgart, and then we would stay drinking and talking up to very late in the night. So the other thing that we did after I left is we met in many meetings. So some in Santa Barbara. So he liked a lot Santa Barbara and Aspen. And that picture is from Aspen in 2009. So we went hiking. So you see these are the Aspen trees. So we had a lot of fun. And I think that's it. That's all I wanted to say about it.
So good afternoon, everybody. My name is Stefan Wessel. I am now at the University of Aachen, but I was in Alejandro's group for a long time. When he started his position in Stuttgart in 1996, he actually managed to get a permanent research employee position with his professorship, and this position was then offered to me in 2004, so that's since when I know Alejandro, and I was there until 2011, then I moved to Aachen. And I was first meeting Alejandro in more detail discussing with him in a KITP school in 2004 in Santa Barbara, which was, as you have already seen, it was a very inspiring time because a lot of new developments in the interface between cold atoms and strongly coded electrons were emerging. And since then, I have made a list here of topics that Alejandro used to work on or was working on since I came to Stuttgart, which is extremely broad, and those who know him know very well that he was really an expert both in numerical techniques, particular quantum Monte Carlo and DMRG methods, but was also doing very heavy field theoretical calculations using RG approaches. And so mastering it all in one person is a very special treat, I think. And so he, as we already seen, he was frequently going to the US, both to Aspen and to KITP. And what you will see is, in comparison to the pictures that are taken in Stuttgart, is that whenever he went on the airplane, he would cut away the beard. He was so scared that he would not be able to enter the US because he would really have a different appearance. Yeah? So one of his latest interests was this field of ADS-CFT duality, which he really liked to discuss or explain what it is about, but unfortunately he was not making new papers with that idea, but he was really fascinated always by the latest ideas, and they could be from very different topics and different fields. So basically life at the Institute was scheduled around the weekly reading list, if I might say. So Alejandro had a very strict schedule of when to read which type of papers. So Monday was the Physical Review Letters Day. Tuesday he would browse through all the first ref, and that could be A, B, and in particular also D, E. And Wednesday, at some point, Alejandro realized that there are actually interesting papers in the proceeding of the National Academy of Science, and the influential paper that started his interest there was actually on cosmology. So that was some paper proposing some new alternative to the cosmic inflation scenario. Don't ask me details. But since then he was reading the proceeding of the National Academy of Science on Wednesday. Then Thursday was Nature, and Friday Science, and it was always like he would read this before lunch so that we had time to discuss things over lunch, and also after lunch we had a coffee break. And this was not only restricted actually to physics, but also going into biology and political statements, and he was very, very interested in discussing this with us, so that was a very nice time. So I stick also now, I still use this schedule, so you have a good schedule what to read when. And these pictures here taken in Stuttgart, you see the beard appearing. And in the background of this lower picture, you see our local cluster that we installed, where we could actually do the numerical simulations that, of course, we had to do in this field, right? So what I wanted to do now is to show 3 highlights of the research that Alejandro was doing while I was sort of in Stuttgart, so I could really experience how progress was made by him and his collaborators. And one idea which is very neat is a methodological idea to come up with a new algorithm to simulate the TJ model, which, as you know, is a constraint model of fermions. And so what Alejandro managed is to make a mapping of that constraint fermion to sort of a slave particle approach, where then you had to simulate 3 fermions that are, so non-interacting fermions that are coupled to spin degrees of freedom. And then the cool point is that these spin degrees of freedom you could then simulate using efficient cluster updates. And so they worked out this algorithm in much detail together with Fakar Assad and these other people here. And then here's an application, this is maybe the major application, where they looked at the spectral functions of the TJ model in 1D. And what is shown here, for example, by the solid lines is the prediction of a supersymmetric version of the TJ model, and they could track certain excitations, namely antiholons, based on that beta ansatz solution, also for the relevant model in the relevant physical parameter space. So later on, me and Alejandro tried to boost this algorithm from 1D to 2D, but then the sign problem really kicks in very severely, so that didn't go beyond one dimension, unfortunately. But it was a very clever trick to combine these different methods. And to actually do this, you had to do a lot of detailed calculations in these representations to come up with the algorithm. Then I should also mention that actually at the time when time-dependent DMRG was developed, the group in Stuttgart was also intensively working on new algorithmic ideas to do real-time evolution with DMRG. So Alejandro's idea was to use the Krylov space approach that maybe many of you know from Langschuss or so. And he had contact with some mathematicians. There were some rigorous bounds of how good the time evolution would be. And so they managed to wrap this into an algorithm. But later time showed that the alternative methods that were developed elsewhere just turned out to be more flexible. But in terms of method development at the right time, when this time-dependent DMRG was sort of in the air, he was really on the fly and doing this. And so then there were a bunch of publications that came out of this, and Marcus Rigol already mentioned some. So very early on, Alejandro was also getting this idea that before terminalization, interesting things could happen, that there's something like a pre-terminalization phase. And at that point, we discussed this very intensively. And that really helped that he could make this crosstalk with very formal work done in the group in Heidelberg, where they developed this idea of pre-terminalization in field theory. So he could really synthesize this with numerical approaches. This was, I think, very, very special. Then, yeah, this is the last paper that was published with Alejandro. So in the later stage, actually, I think Alejandro came back to something that you are also very interested in, Paco, namely graphene and physics of strongly correlated electrons on graphene. And we did various studies, and this is the last one that involved a generalization of sort of a constraintless TJ model to an SUN symmetry, and we looked in details of the phase diagram. And there also it was crucial to have somebody in the group who has really an insight into all these effective theories that were developed to describe, large N theories, and how would you link that to the physical ends and so on. So that was very much insight needed from Alejandro there. So that was for me a very impressive open mind that would always be curious about the latest developments and really take, not only just looking at them, but really using them in his own research interest. And it was a very inspiring time ever since when we were together. So maybe also I end with an anecdote. You already mentioned, Marcus already mentioned, that Alejandro was a very fascinated swimmer, and he would not leave out any opportunity to take a swim. So once we were in a workshop somewhere in the French mountains, and on the last day we were stationed in Nizza, in a hotel in Nizza, very close to the beach. Very beautiful view from my hotel window to the beach. And I could see Alejandro walking out of the hotel, just his swimming suit and a towel, going for a swim, fine. But actually at that day I learned that Alejandro is maybe the first person that would come to a wedding ceremony with just a swimming suit. How did this happen? Well, so he left, he went to a swim, and when he came back, before he came back, there was a wedding ceremony that was sort of having their picture taking in front of this hotel. So there were like 100 people, and the bride and the bride, and he would walk back to the hotel throughout all these people. So I don't know if he's actually on any of these pictures, but yeah, that was a very nice story that I remember. And so I thank you very much for offering, or the organizers here, for offering us the opportunity to speak of our heart a little bit about Alejandro and the memory we will keep in our hearts of him. And I hope I have been able to share a little bit this feeling that he imposed in us. And thank you very much for your attention.
So we still have 5 minutes. I don't know if you need, so I heard Daniel Huerga also knew Alejandro, if they want to say a few words. Like you in Torino, if you like to say just a few words about Alejandro in Torino. I remember he was there a lot.
Well, I met Alejandro, of course, many times.
Yeah,
and,
but I recall Torino
I knew
because-
this story about nature, and I found that very interesting. Told me once that really Thursday morning, that was nature for him, and he was carefully reading, and I always was impressed by that, because then I told myself I should do that also, because nature is very interesting, and just take 2 hours every week for nature. I was completely unable to do that, so now I hear that it was even others like PNIS and all these things. I think what was said also already here, what I found fascinating with his research was that he was really an excellent field theorist. He knew these different representations of spin operators, and he had very close collaborations, for instance, with Morandi and these people in Bologna and others, really field theorists. And at the same time, he did all this great work on quantum Monte Carlo. What was not mentioned was this paper recently on, well, it was mentioned that he worked on graphene. But as you all probably know, there was this fantastic intermediate phase they found in graphene. So the question of the mod transition being just a second order transition, or like the MFT people like to say, it's a first order transition. So they came up with the idea that maybe there is an intermediate spin liquid phase in the graphene. Turned out not to be correct, and I saw how he reacted, and it was actually here in Évora where there was a discussion between Sandro Sorella and Alejandro Muramatsu. And this was great. I mean, if you are used to debates in the ITC community, say Alex Müller on the one side speaking for polarons, and on the other side Phil Anderson and saying this is all bullshit, or even also Chandra Varma once he said, when people were speaking about electron-phone interaction, this is phonons. That's ridiculous. So that was Chandra Varma. So the atmosphere there in this ITC community, sometimes it was really a little bit awful. But here, Sandro Sorella, he just went on to much larger system sizes, and then he discovered that this spin liquid phase faded away. And Alejandro, he was really a gentleman.
Yes.
He said, okay, I can accept that, these are data, and this is really a scientific, open-minded spirit, which I really admire a lot. Okay.
Thank you. I heard that Daniel Huerga was on you a little bit, Alexandro. Is it true, or was...
I am Daniel.
Sorry.
Yeah.
You also had some interaction with him?
Yes.
Okay, just 2 minutes, you can say a
Okay.
few words.
So just.
Sorry, I was...
I joined.
you are Ares, yes, sorry. You are Daniel
I
Huerga.
joined Alejandro's team just in 2014, and probably it was maybe a little bit hard time because he already knew about his disease, and well, for me it has marked, although it has been very squeezed time, it has marked the way we discussed in the blackboard, and the way time had another, and physics had another significance when discussing with him. And also political issues that he was very active, and I enjoyed a lot to share with him and to discuss, always very intensive. So, yeah.
Okay, so we close here. So now we have a 1 hour clock.